Welcome to today's lesson, students. So, I'm going to continue with the extra questions of grade 11, unit 9, heat lesson. So, this is extra question 17. The zero values of the Celsius and the Fahrenheit scales have been chosen according to the wishes of the people who introduced them. So, you are familiar with the different scale, students. They were introduced by different scientists. So, depending on the wish of the scientists, they have assigned values for the lower fixed point and the higher fixed point. So, as you are familiar with the different scales of temperature, students, you all can remember in Celsius scale, the lower fixed point is 0 degrees Celsius and the higher fixed point or the upper fixed point is 100 degrees Celsius. That is the boiling point of water. So, based on that, there are 100 divisions between the lower and the upper fixed point. So, whereas you can remember in the Fahrenheit scale, students, 32 degrees Fahrenheit is the melting point of ice, that is the lower fixed point, and 212 degrees Fahrenheit is the upper fixed point. So, that is the boiling point of water, and therefore, in between there are 180 divisions. So, these values were based on the wishes of these two scientists. So, the lowest value 0 degrees Celsius and 32 degrees Fahrenheit were by the scientists who introduced them. However, there is a minimum value to the temperature that any object can reach. So, although we say lower fixed points, below that also there is temperature. You all are familiar with minus degrees Celsius, minus 10, minus 20, minus 30. Similar to that, even in Fahrenheit, there are minus temperatures. The reason is below this lower fixed value, there is temperature. But once you keep on removing the heat from an object, the heat is lost and finally the object reaches a point where it does not have any mean kinetic energy. That means the temperature is completely zero, and that was introduced by a different scientist. That is what we say as the minimum value to the temperature that any object can reach. So, that is where there is no mean kinetic energy in the object. And this was introduced by who introduced this concept? That is the question. That was introduced by Lord Kelvin. So, you know the answer to this question. Lord Kelvin. Then the second question. What is the name given to the lowest temperature introduced by the scientists you mentioned in part 1 above? What is the lowest temperature? It is called the absolute zero temperature. So, here the answer is absolute zero temperature. Absolute zero temperature. Then we have the third question. What is the value of the temperature you mentioned in part 2 above? That is absolute zero temperature in Celsius scale. So, equivalent to absolute zero temperature. You all can remember the value is 0 Kelvin. What is the equivalent value in Celsius scale? Minus 273.15. That is the exact value. So, if we write the answer minus 273.15 degrees Celsius. But for calculation, students, you all can remember we use the value as 273 degrees Celsius. But in real, the exact value is minus 273.15. So, if I go back to the three questions, the zero values of the Celsius and the Fahrenheit scales have been chosen according to the wishes of the people who introduced them. However, there is a minimum value to the temperature that any object can reach. Who introduced this temperature or who introduced this concept? That is Lord Kelvin. And what is the name given to that lowest temperature introduced by the scientist you mentioned in part 1 above? That is called the absolute zero temperature. That is 0 Kelvins. And what is the value of the temperature you mentioned in part 2 above in Celsius scale? That is equal to minus 273.15. So, I am sure students, you all were also able to answer all these questions correctly. So, with that, we will move on to the next question. Extra question 18. What is the melting point of ice in Kelvin scale? So, you all know the melting point of ice. What is it? That is 0 degrees Celsius. So, if it is in Kelvin scale, what is the value? It is 273 kelvins. So, here it has to be 273 kelvins. What is the melting point of ice in Kelvin scale? If you can't remember, how can you find the value? You all know the conversion. If it is degrees Celsius, if you add 273, you get the Kelvin scale. So, since you know the melting point as 0 degrees Celsius, if you add 273, you get the value as 273 kelvins. Then we have the next question. What is the boiling point of water in Kelvin scale? So, again, boiling point of water is 100 degrees Celsius. You can immediately remember the boiling point of water as 373 kelvins, or else with 100 degrees Celsius, if you add 273, you know the value will be 373 kelvins. So, for the Kelvin scale, you all are familiar with that. We don't use the degrees. For Celsius and Fahrenheit, we use it as degrees Fahrenheit. But here, it's just Kelvin, and that is the standard international unit of measuring temperature. Then the next question. I have already answered the question. Write the standard international scale and the unit of measuring temperature. What is the standard international scale? That is the Kelvin scale. Kelvin scale. So, what is the unit of temperature? That is kelvins. In both these, since these are names of scientists, you have to always use the capital letter. Even for degrees Celsius, degrees Fahrenheit, because those are all after the scientist who introduced the scale, you have to use capital letters. So, I am sure students, you were also able to answer all these correctly. Melting point of ice in kelvins, 273 kelvins. Boiling point of water in Kelvin, 373 kelvins. And the standard unit is Kelvin, and the scale is the Kelvin scale. So, with that students, I will move on to the next question. Extra question 19. How do you convert a temperature from Kelvin scale to Celsius scale? Already I have discussed that with the previous question also. What do you do? To degrees Celsius scale, if you add 273, you will get the Kelvin scale. So, that is what you have to write here. So, here you can say by adding 273 to the Celsius scale, Kelvin scale is obtained. Or you can even say the Kelvin scale can be obtained by adding 273 to the Celsius scale. So, if you want to make it more clear, to degrees Celsius, if you add 273, you get the Kelvin scale. That is the equation. So, then we will move on to the next one. There is water at 80 degrees Celsius in a container. Write the temperature of water in Kelvin scale. So, we can directly use this equation. What is the temperature? 80 degrees Celsius plus 273, you will get the Kelvin scale. So, 80 plus 273, it is 353 kelvins. So, there is water at 80 degrees Celsius in a container. Write the temperature of water in Kelvin scale. that is 353 Kelvin. If you want, you can rewrite it saying the temperature of water is 353 kelvins. Or you can show this working on the side and you can write the answer here. Either way, it is fine. So that is the temperature in Kelvin scale. Then, the third part of the question, temperature of a block of iron is 323 kelvins. What is the temperature in Celsius? So to do that, or to find the temperature in Celsius, or to convert Kelvin to Celsius, what do we do? You have to subtract 273 from kelvins. Why? The equation is degree Celsius plus 273 giving rise to Kelvin. So if you want to find the degree Celsius from Kelvin, you need to subtract 273. So here the value is given as 323 kelvins minus 273. That will be equal to 50 degrees Celsius. So that means 323 kelvins equals 50 degrees Celsius. So they wanted you to convert the temperature. Temperature of a block of iron is 323 kelvins. What is the temperature in Celsius? So that is equal to 50 degrees Celsius. The same way here also we can write 80 degrees Celsius equals 353 Kelvin. So that is how you get the different temperatures. Here this is not an equation, students. We are showing the temperature in two different scales. 80 degrees Celsius equals 353 kelvins. The same way 323 kelvins equals 50 degrees Celsius. So I am sure you were able to do these calculations correctly. So with that, students, I will move on to the next question. Extra question 20. Using solar power to heat water is a very efficient method in terms of utilizing renewable energy sources. So you are familiar with renewable energy sources. Normally, there are some energy sources that we can run out of it with time. But the sun's energy, that is solar energy, is available to us throughout. So it is a renewable energy source. So using that to heat water is an efficient method, not only because it's renewable and also because it is very environment friendly. So due to these reasons, it is a very efficient and useful method. A setup used in the household to heat water using solar power is shown below. So here a diagram is given to you, students. You all can see there is the solar panel. So you are familiar with this. You have seen the solar panels. They absorb the sunlight and they convert the sunlight either to electricity or that is converted to heat here. Actually here it is converted to electricity. And then there is a heating coil, so that electricity is supplied to the heating coil. Therefore, the water inside the tank will be heated. So these are solar heaters. If we produce electricity, we call it the solar cells or solar panels. But here, this is a solar power water heater. So the solar therms or solar water heaters. You are familiar with that. So here is the solar panel. Then here you can see there is a black color surface and there is a pump through which the heat is transferred or heat is conducted into this water tank where you have the heating coil. And here you can see it is the water tank, and here you can see there are two pipes through which you can either send water in or draw water out. So those are the two water transferring pipes. So those are the parts of this solar power used to heat water, that particular system. So now we will look at the questions based on this particular diagram. The first one. Write the method of heat transfer taking place in the instances given below. So the first instance, transfer of heat from sun to the solar panel. From the sun to the solar panel, you all know there are three methods of heat transfer. And the first two methods, conduction and convection, they need a medium for the heat transfer to take place. But from the sun to the solar panel, there is vacuum. So there it has to be the third method, radiation or thermal radiation. So here this is going to be radiation. Then the next one, transfer of heat from heater to water in the tank. So here you can see, students, from the solar panel, from this part, you can see the metal, that is a strip of metal or a metal rod we can say. So here it is a solid, this is a solid. And here you can see we have the coil, this is the coil. So it is a metal solid. So, and there is a coil, that means through a solid, what is the method of heat transfer? The first method, that is conduction. So, transfer of heat from heater to water in tank. So, that is going to be the conduction process. Conduction process, transfer of heat from heater to water in tank. So, those are the first two questions. Then I will move on to the next one. State the advantage of having a black color surface behind the solar panel. What is the advantage? Now, you are familiar with heat radiation and how the nature of surface absorbs heat radiation. Black colored rough surfaces absorb heat radiation more. White color or light color surfaces, shiny surfaces, smooth surfaces, they reflect heat radiation more. So, black color absorbs more, reflects less. Whereas white or light color, shiny, smooth surfaces absorb very less heat radiation, but they reflect more heat radiation. So, because the surface is black colored here, what happens? It can absorb a higher amount of heat radiation and transfer it to this solar therm. So, from there will be heat conducted to the heating coil. So, that is an advantage. That is the reason why they have black color surface behind the solar panel. So, here we can say black color surface absorbs thermal radiation more. Therefore, higher amount of heat radiation will be absorbed by the solar panel. Then we have the third question. What is the function of the tubes X and Y? So earlier also, students, I told you all X and Y tubes are there either to send the water in or draw the water out. I have explained this to you all when I discussed the lesson. In water, it is a liquid. So how does heat transfer take place? By convection. Convection means the particles of water, they absorb heat, and when they increase in temperature, they tend to expand. Due to expansion, the density of water decreases. So, therefore, the hot particles of water tend to rise up. And the cool particles that are at a higher level, they move downwards. And there is a circular or circulation of water particles, and that is known as the convection current. So what will happen when there is heat provided by the heating coil? All the hot water will tend to move up, whereas the cool water will tend to move down. So which is the best way? It is better to send water in through Y and draw water out from X. So you send the water or pump the water into the water tank with the heating coil from the Y tube that is below, and take the hot water out from X that is at a higher level. So here the question is, what is the function of the tubes X and Y? So here we can say, you can see students, X to draw hot water out and Y to pass cool water into the tank. So X to draw the hot water out and Y to allow the cool water to flow into the tank. Then we have the fourth part of the question. Explain your answer in part 3 above. So I have already explained you all the answer. Water is a liquid, therefore heat transfer takes place by convection. That is what you have to write here. So here, water is a liquid, thus heat transfer takes place by convection. So here we can say, during the convection process, hot water rises up and cool water moves down. So it is efficient to draw out the hot water using pipe X, that is at a higher level, and pump or allow water to flow into the tank through pipe Y, that is at a lower level. So students, I will go back and discuss the answers again with you all. So the Second question, state the advantage of having a black color surface behind the solar panel. Black color surface absorbs thermal radiation more. Therefore, higher amount of heat radiation will be absorbed by the solar panel. So that is why the surface is black in color. Then we have the second one. What is the function of the tubes X and Y? X is used to draw hot water out and Y is used to pass cool water into the tank. So that is the function of tubes X and Y. Then we have the fourth part. Explain your answer in part 3 above. Water is a liquid, thus heat transfer takes place by convection. During the convection process, hot water rises up and cool water moves down. So it is efficient to draw out the hot water using pipe X that is at a higher level and pump or allow water to flow into the tank through pipe Y that is at a lower level. So this is how students you all are supposed to answer these questions. So I am sure you also would have written a similar answer. With that, I will move on to the next question. Part 5. It is required to heat 250 kg of water from 10 degrees Celsius to 50 degrees Celsius every day using the above solar panel. So daily they have to heat 250 kilograms of water. So that's a very large amount of water. So here you can see students the mass of water that is M that is equal to 250 kilograms of water, and then you can see the change in temperature that is going to be theta 50 degrees Celsius minus 10 degrees Celsius. So that will be 40 degrees Celsius. So then we need to calculate the heat that needs to be supplied by the solar panel. So that should be equal to the heat that is going to be absorbed by the water in order to increase in temperature by 40 degrees. So there, if we use the same equation, you are familiar with this by now, MC theta. So M is 250 kilograms. C is given to you 4200 joule per kilogram per Kelvin, and the temperature 40, and here as I told you degrees Celsius and Kelvins, you are familiar with that. They are both equal when it comes to difference. So if we consider the calculation there, kilogram and kilogram minus 1 get cancelled off, Kelvin minus 1 and Kelvins get cancelled off. So there 250 into 40 you can easily multiply and write. So 25 into 400 and you need to put 2 more zeros. So it becomes 10,000 and then into 4,200 joules. So there you will get the value as 442 million joules. That is the amount of heat that is needed to be supplied by the solar panel every day in order to heat 250 kilograms of water from 10 degrees Celsius to 50 degrees Celsius. So this can be rewritten as you all know, you can write it this way, 4.2 into 10 to the power of 7 joules. There are 3 6 zeros and 4.2 means 10 to the power of 7 joules. Or else at least you can rewrite it as 42,000 kilojoules, or you can leave it as it is 42 million joules. Anything is fine as long as you do the calculation correctly. So here we had to calculate the amount of heat that is, or calculate the energy that needs to be supplied by the solar panel every day in order to calculate 250 kilogram of water from 10 degrees Celsius to 50 degrees Celsius. So you use the same equation and you can find the value there. So I'm sure students, you were also able to answer this question correctly. So with that, I will move on to the next question. Extra question 21. So in that, the first one, what is melting point? So here students, you all know what melting point is. What is it? The temperature at which a solid substance gets converted from solid state to the liquid state on heating. So that is known as the melting point. So that is what you need to write here. The temperature at which a solid substance undergoes state change from solid to liquid. So here you can see the temperature at which a solid substance undergoes state change from solid to liquid. We have to also specify on heating is known as the melting point. So you all know that students, when there is a state change, we have to provide heat or we have to supply heat, but the temperature does not change. That is why we have a fixed value as the melting point for a particular solid substance. The same way, if we look at the second question, what is boiling point? What is boiling point? Again, at a fixed temperature, when you provide heat, the state changes from liquid to gas, or liquid becomes vapor. And there is boiling taking place or bubbling taking place in the liquid. That is what we call as boiling point. So if we write the answer there, the temperature at which a liquid boils, or you can say temperature at which a liquid is converted to vapor by forming bubbles. So you can say is known as boiling point. So here you can look at the two answers. What is the boiling point? The temperature at which a liquid boils, or temperature at which a liquid is converted to vapor by forming bubbles is known as boiling point. So one of the two can be used as the answer for this. What is boiling point? The third one, what is freezing point? So you all know students, the freezing point and melting point have the same values when it comes to the same substance. So for example, if you take ice melts at 0 degrees Celsius and forms water on heating, whereas water freezes and forms ice at the same temperature 0 degrees Celsius but on cooling. So the freezing point means the temperature at which a liquid substance undergoes state change from liquid to solid without a change in temperature. So that particular temperature is known as freezing point. So if we write that answer here, the temperature at which a liquid undergoes state change from liquid to solid on cooling is known as freezing point. So what is freezing point? The temperature at which a liquid undergoes state change from liquid to solid on cooling. So when it's from solid to liquid, it's on heating. Here from liquid to solid, it's on cooling. Is known as freezing point. So we have answered all the questions, students. I'm sure you were also able to write or define all these different temperatures. Melting point from solid to liquid. Boiling point, liquid to vapor. And freezing point, liquid to solid again. So those are the melting point, boiling point and freezing point of different substances. With that, I will move on to the next question. Extra question 22. What is meant by latent heat? What is latent heat, students? The heat that is absorbed when there is a state change taking place without a change in temperature. That is what we call as latent heat. So you all know, students, when ice melts and forms water. So there is a state change from solid state to the liquid state. There, in order to break the intermolecular bonds that are present in the solid state, have to be broken down. So to do that, we need to provide heat. And that is the heat that is absorbed as latent heat. So because it is used to break the bonds, there is no increase in temperature. So here, if they ask you to write what is meant by latent heat, you have to say the amount of heat absorbed by a substance when there is state change taking place without a change in temperature. So that is what we call as latent heat. Then the second question, what is meant by fusion? What is fusion, students? The conversion of state or change of state from solid state to liquid state is known as fusion. Another name, melting. So here, what is meant by fusion? The change of state from solid to liquid is known as fusion. Then we have the third question. What is meant by latent heat of fusion? So what is latent heat of fusion? When there is a state change from solid state to liquid state at the melting point, the amount of heat that needs to be supplied for that change to occur is known as the latent heat of fusion. So if we write that down, the amount of heat required for a substance to undergo state change from solid to liquid at its melting point is known as latent heat of fusion. Then the fourth question. What is meant by specific latent heat of fusion? What is specific latent heat of fusion? If there is 1 kilogram of a solid substance at the melting point, the amount of heat that needs to be supplied in order to convert that substance into its liquid state is known as the specific latent heat of fusion. So here, if we write the answer, the quantity of heat, or within brackets I will say amount, you can use any term, the quantity of heat required to convert a unit mass of a solid substance at its melting point to the liquid state is known as specific latent heat of fusion. So I will go through all the answers again. The first one, what is meant by latent heat? The amount of heat absorbed by a substance when there is a state change taking place without a change in temperature. That is known as latent heat. Then the second one, what is meant by fusion? The change of state from solid to liquid is known as fusion. Then the third one, what is meant by latent heat of fusion? The amount of heat required for a substance to undergo state change from solid to liquid at its melting point is known as latent heat of fusion. Then if we look at the fourth one, what is meant by specific latent heat of fusion? The quantity or amount of heat required to convert a unit mass of a solid substance at its melting point to the liquid state is known as specific latent heat of fusion. So you all know normally when we say unit mass, we refer to 1 kilogram of substance. Why? Because kilogram is the standard unit of measuring mass. So there you can also write as 1 kilogram of a solid substance. I am sure you were able to write all these answers correctly, students. So with that, I will move on to the next question, extra question 23. The specific latent heat of fusion of ice is 3.36 into 10 to the power of 5 joules per kilogram. What is meant by this? So what is the meaning of that? If there is 1 kilogram of ice at its melting point, that is 0 degrees Celsius, to completely convert the ice to water, that is 1 kilogram of water, the heat that needs to be supplied is known as the specific latent heat of fusion. So that is what you have to explain and write here. So if we write that, so the amount of heat that needs to be supplied to 1 kilogram of ice at its melting point that is 0 degrees Celsius to convert it to water at the same temperature is 3.36 into 10 to the power of 5 joules. So that is what is meant by specific latent heat of fusion of ice is 3.36 into 10 to the power of 5 joules per kilogram. The amount of heat that needs to be supplied to 1 kilogram of ice. This is a must here. You have to say 1 kilogram of ice at its melting point, that is 0 degrees Celsius, to convert it to water at the same temperature is 3.36 into 10 to the power of 5 joules. So then we have the next question. What is meant by the latent heat of vaporization? What is latent heat of vaporization, students? It is the amount of heat that needs to be supplied to a certain substance at its boiling point in order to convert it to the vapor at the same temperature is known as the latent heat of vaporization. So here if we write the answer, the amount of heat that needs to be supplied to a liquid substance at its boiling point to convert it to the vapor at the same temperature is known as the latent heat of vaporization. So here students, you can see the amount of heat that needs to be supplied to a liquid substance at its boiling point to convert it to the vapor at the same temperature is known as the latent heat of vaporization. So then we have the third part. The specific latent heat of vaporization of water is 2.26 into 10 to the power of 6 joules per kilogram. What is meant by this? So you have to define or explain what that is. So when there is 1 kilogram of water at its boiling point, Then to convert that water to its vapor or to steam, we need to supply a heat of 2.26 into 10 to the power of 6 joules. So that is what is meant by latent heat of vaporization of water is 2.26 into 10 to the power of 6 joules. So here we can say the amount of heat that needs to be supplied to 1 kilogram of water at 100 degrees Celsius, or within brackets I will say at its boiling point to be converted. Here, since we say water, we can directly write steam. Converted to steam at the same temperature is 2.26 into 10 to the power of 6 joules. So that is what we understand from specific latent heat of vaporization of water is 2.26 into 10 to the power of 6 joules per kilogram. So if I go through the answers again, first one, the specific latent heat of fusion of ice is 3.36 into 10 to the power of 5 joules per kilogram. What is meant by this? The amount of heat that needs to be supplied to 1 kilogram of ice at its melting point 0 degrees Celsius to convert it to water at the same temperature is 3.36 into 10 to the power of 5 joules. Then we have the second one. What is meant by the latent heat of vaporization? The amount of heat that needs to be supplied to a liquid substance at its boiling point to convert it to the vapor at the same temperature is known as the latent heat of vaporization. Then the third one, the specific latent heat of vaporization of water is 2.26 into 10 to the power of 6 joule per kilogram. What is meant by this? The amount of heat that needs to be supplied to 1 kilogram of water at 100 degrees Celsius, that is at its boiling point, to be converted to steam at the same temperature is 2.26 into 10 to the power of 6 joules. So that is what you understand from all these questions. And I am sure since you all have understood what these different values are, you were able to answer the questions correctly. So with that, students, I am going to move on to the next question, extra question 24. So here the first one is write the 3 methods of heat transfer. A very simple question. What are the 3 methods of heat transfer? Conduction, convection and radiation. So here conduction, convection and radiation. So then the second one. What are good thermal conductors? What are good thermal conductors? Solid substances that conduct heat well are known as good thermal conductors. So here we can say solid substances that conduct heat well are known as good thermal conductors. Then we have the third question. Write 3 examples of good thermal conductors. Here students, you all know the metals are very good thermal conductors. So as metals, we can write any example. You all know mercury is a metal, but it is a liquid metal. But when we discuss the glass mercury thermometers, we say mercury is a very good thermal conductor. That's why we select it as the liquid for thermometer. So that is one example. The same way, if you take copper, iron, those are all metals, even aluminium. They also conduct heat very well. They are very good thermal conductors. The same way, the metal alloys. If you take brass or steel, those are alloys of metals. They are also very good conductors of heat. So those are all coming under good thermal conductors. You have to write 3 examples of good thermal conductors. So I will write 3 different examples. Mercury, because it is a metal in the liquid state. Then I will say aluminium, that is a metal, a pure metal, and let's say steel, this is an alloy. So all these are good thermal conductors. And you all know why metals are good thermal conductors. Why is that? When you take the metal lattice, the nucleus with the electrons is there as the positive charge, and the valence electrons are free to move around. That is the structure of the metal lattice. So because of these free electrons as well as the vibration of the nucleus, it is very easy to conduct heat from one end to the other end. So there are nuclei or the atoms that vibrate as well as free electrons that vibrate to conduct heat. So therefore metals are good thermal conductors. So I am sure students, you were also able to answer all these questions correctly. The first one, the 3 methods of heat transfer: conduction, convection and radiation. Then the second one, what are good thermal conductors? Solid substances that conduct heat well are known as good thermal conductors. And the third one, write 3 examples of good thermal conductors: mercury, aluminium and steel. So with that students, I will move on to the next question. Extra question 25. What are insulators of heat? What are insulators of heat? Substances that cannot conduct heat well are known as insulators of heat. So here, solid substances or you can even leave out the word solid, that is okay, because we say water and air are poor thermal conductors. So here, substances or solid substances that cannot conduct heat well are known as insulators of heat. Or you can just say insulators. So solids or substances or solid substances that cannot conduct heat well are known as insulators of heat or thermal insulators. Then the next one, write 3 examples of insulators. You all can remember we have discussed different examples. Wool is a material that is an insulator of heat. That is why normally in cold countries to make jerseys or sweaters, they use the wool material to prevent or keep the body warm from the environment temperature, because it is a very good insulator of heat. Then there is clay. Clay is an insulator of heat. There is wood, that is an insulator of heat. Plastic containers, they also don't allow heat to be conducted, or they don't conduct heat that well. That is why in thermos flasks and most of these thermos containers, their outer casing is made out of plastic. So plastic is a thermal insulator. Then there is asbestos. You all are familiar with the asbestos sheet and all those. They also do not conduct heat well. So those are insulators. So we can write any of those three examples here. Write three examples of insulators. I will write wool, then plastic and wood. Wool, plastic and wood. Those are three insulators. Write three examples of insulator. So with that, students, I have come to the end of the 25th question. Again, I am discussing extra questions. I will discuss more extra questions in the next chapter. So I have completed this chapter for now.